Quantitative risk analysis. In this video, we will learn the conceptual basis for calculating disaster risk quantitatively. We will begin by defining both risk and quantitative risk analysis. A quantitative risk analysis of natural disasters is the numerical estimation of the probability of occurrence of certain natural events and their consequences in social or economic terms. Therefore, the result of a quantitative risk analysis is expressed in terms of the number of affected persons or the value of economic losses. A quantitative risk analysis requires answering three questions. What can happen? How likely is it to happen? If it happens, what are the consequences? To quantitatively estimate this, we divide risk into three basic components: hazard, vulnerability, and exposure. Hazard refers to the probability that a certain event will occur in a certain place and with a certain intensity. When we talk about natural disasters, events can be floods, landslides, rising sea levels, and so on. The variables that characterize intensity change based on the hazard. In the case of floods, variables are the flood's height and speed. And in the case of earthquakes, a variable is acceleration. Vulnerability is the conditional probability of the response of the infrastructure or system to the hazard's intensity. We can express it numerically as a value, ranging from 1, which would be the total loss of the infrastructure or system, to 0, in which the hazard's intensity does not affect the infrastructure or system at all. Lastly, exposure is the quantitative identification of people or infrastructures that are in the study area where the hazard occurs. By analyzing the hazard's probability and intensity, estimating the assets and persons exposed to the hazard, and their vulnerability to the hazard, we can estimate the probability of losses and consequences. The effects of global climate change are increasing and will continue to increase the probability and intensity of natural hazards in Latin America and the Caribbean. This creates new challenges for analyzing disaster risk, as it increases the uncertainty in the estimation of the hazard's probability and intensity and, therefore, in the calculation of risk. In this course, we will see the main methodologies used for estimating risk, considering climate change scenarios and their associated uncertainty. In summary, risk is a combination of probability and consequences. It can be quantitatively estimated, considering climate change uncertainty, by applying appropriate techniques.